Okay, and here's how we solve question 3. So we have a mass sitting on a ramp, small m, sitting on a ramp, with a frictionless pulley connected to a large mass hanging off the side. So force of gravity is acting on that mass, obviously. So let's draw some of the forces we have acting here. Gravitational mass is pushing down on this. So it's going to be capital M times G. Gravitational force, the tension force will be pulling up. We have gravitational force here, little m times G. We have the normal force. And we're looking for the largest m for the angle you choose for the ramp. The largest m that can be put here, largest capital M, that results in zero acceleration. So anything bigger than that, and it's going to start accelerating, presumably falling down and pulling the other mass up the ramp. So if we're trying to figure that out, we're assuming friction is working with us, or friction is working with us. We're trying to get it moving this way, or not to get it moving this way, which means friction is going to be acting in this direction. So if we put this together, first step, of course, is to draw our free body diagram. Let's identify that angle so we remember what we're talking about here. If we orient things again so that we have a horizontal, we have the tension force, which is going to be equal to mg, because this mass is going to be staying in equilibrium. It's not going to be moving. In the other direction, we have force of friction, which is mu times the normal force, and we have Fgx, which is equal to little m g sine theta. So putting this together, also remember, let's draw the vertical stuff for little m. This is little m we're looking at here, by the way. So for little m, we have the normal force acting in the vertical direction, and we have Fgy, which is equal to mg cos theta. And those are all of the forces acting on that mass, so we can decide what's going to accelerate that mass. It's coming down here. To get the net force acting on this, we would add all these forces up. We're looking for the biggest number we can put in here that will result in zero acceleration. So we're looking for the biggest number here at equilibrium for the rest of it. So let's work that out. What that means is this value here is going to be equal to these two values here. So mg is going to be equal to little m g sine theta plus mu s Fn. Now the normal force we just established is going to be equal to Fgy. So let's rewrite this, mg sine theta plus mu s mg cos theta. Now, to work this one out, again, we're going to be solving for big M, the largest value of big M that allows us to do this. So the first step we can take here is we can cancel out all of our g's, because every single term in here has little g in there, so we can remove them. At this point, we know this is 10 kilograms. You have chosen an angle, so you're going to place your value in there, and mu s is 0.4, and you can solve for your final answer.